Hi everyone, I am Dr. Kiran, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. So today's session, I will cover Bipolar Junction Transistor, BJT, which is a basic electronic component which is used in different applications. So let us see what is the overview of today's session. So start with the introduction. So we'll cover transistor concept, BJT, bipolar junction transistor, and types of bipolar junction transistor, NPN and PNP, then construction and operation of these NPN and PNP transistor, then different configurations of the transistor, and then conclude with summary. So first, let us start with the transistor concept. So it is first invented by William in 1951. So after invention of this transistor, so there is a drastic change in the electronic industry. Previously, in the past, vacuum tubes are used for amplification purpose, so which occupies more space. So after invention of this transistors by William in 1951, so more space is reduced, or we can say the space required for the component placement of the component is reduced drastically, and it gives more advantages compared to vacuum tubes. So these transistors are used for amplifying electronic signals, particularly radio signal and television signals, and it is the essential component of every electronic circuit. So you can take any integrated circuit, so you find this transistors, and thousands of transistors are placed in a single chip. So that is because of VLSI technology. So transistors replace vacuum tubes because they are low operating voltage. So transistors, BJT transistors require low operating voltage, and then it gives high efficiency, and it requires less space. That means because of its small size and ruggedness. So when size reduced, obviously ruggedness also increases, and do not require any filament power. So these are the advantages of transistor or other components. So transistor, the structure, particularly the transistor, is a 3-terminal 2-junction semiconductor device. That is 3-terminal. So it has 3 terminals. What are the 3 terminals? The 3 terminals are emitter, base, collector. EBC, emitter, base, collector. And these are, we have a unipolar junction transistor and bipolar junction transistors. So unipolar junction transistor means what? The operation depends on either electrons or holes. Whereas bipolar junction transistor means the operation depends on both electrons and holes. Okay. So let us see in detail about this bipolar junction transistor, BJT. So first of all, let us know what is transistor. Transistor means transfer resistance. So that means the signals are transferred from low resistance region to high resistance region. That is, for example, so this is a transistor, for example. So here, this is low resistance region. What do you mean by low resistance region? Low resistance region means high current. So there is current flowing through this input. High current is there in the inside input, and this signal will transfer to the high resistance region. High resistance region means what? So zero current. So hence we can say transistor can be termed because the signals are transferred from low resistance region to high resistance region. Hence it is called transfer resistance means transistor. So it is a 3-terminal. So what are the 3 terminals? Emitter, base, and collector, and 2-junction device. So after connecting two PN junctions. For example, here if you observe this, we have two types of transistors, NPN and PNP, based on their physical structure and doping concentration, doping level of doping. Based on level of doping, there are two types, right? So NPN transistor, if you consider NPN transistor, here NP, so there are two junctions between this PN junction and between this PN junction. So we have junction 1, junction 2. Two junctions are there. Similarly, PNP. So this is one PN diode. This is junction 1 and this is junction 2. Right? So like that we can say, and the three terminals are, this is base and this is emitter and this is collector. So 3 terminal 2 junction device. And emitter. So coming to the doping concentration, emitter is heavily doped because it's supposed to supply more charge carriers, more number of charge carriers, and base is lightly doped and collector is moderately doped. And if you consider physical area of these regions compared to remaining base and emitter, collector region must be it has more size compared to remaining base and emitter, because it's supposed to dissipate some power, hence its area must be high. Okay, so this is NPN transistor and this is PNP transistor. So see here, it's symbolic representation of NPN and PNP transistor. So this is your base and this is emitter and this is collector. See here, this arrow, how to recognize NPN and PNP transistor. Here arrow indicates here emitter current flowing out of the transistor, i.e. this arrow indicates emitter current flowing out of the transistor, so that is coming out from the transistor. So hence we can say emitter current is flowing out of the transistor, means it represents NPN transistor. Whereas here if you observe here, the emitter current is coming into the transistor. Hence we can recognize this as PNP transistor. What about the other currents? Base current. So base current enter into the transistor. At the same time here collector current also enter into the transistor. Here also base current coming out of the transistor and collector current also coming out of the transistor. So that is the the 3 currents will flow through the transistor. Okay. Next, transistor biasing. So this is very important process, particularly in order to maintain proper operating point, we have to bias the transistor. The transistor biasing. Biasing means, general sense, biasing means adding external DC voltage to the transistor. So here input side emitter base junction is forward bias and output section collector to base junction must be reverse bias. So actually this setup is for amplification purpose, and emitter current flow into the collector. So that is the main concept of transistor. Emitter current means input side. So input current will flow through the collector side. So emitter current is flowing as a collector current, IC. Okay. So if you observe this, the biasing, emitter side, that is emitter base junction. Emitter base junction means this one. This is the voltage between these two, VBE you can say. Or actually here this is base is grounded, no? So base is grounded means this is VEB. And the voltage across this VCB. Right? So here emitter side or emitter base junction is forward bias and collector base junction is reverse bias. Okay. So this is the biasing. So these are the biasing voltages, VBE, and so actually we should write VEB. So because emitter is a top potential, top polarity, so we have to write VEB. And here also for PNP transistor, see here the main concept here, you can check N is connected to negative of the battery. So N type semiconducting material is connected to negative of the battery. So therefore we can say this is forward bias. Here N is connected to positive of the battery. That means reverse bias. So here P side is connected to positive of the battery. Hence it is forward bias. And P side is connected to negative of the battery. So it is reverse bias. So this is mainly for amplification purpose. So we can say if input is, so we have a input output, okay, and what is the application? So if input is forward bias and output is reverse bias, then it can be used for the amplification purpose, okay. And if input is forward bias and output is also forward bias, then we can utilize this as switch, particularly on switch. Your transistor can be utilized for switching purpose. Similarly, if the both reverse bias, then we can say it is off switch, right? So in detail explanation of about this configuration in later sessions we will discuss about this, okay. So this is basic overview of transistor. So BJT working and current components, its current components. The emitter based junction is forward bias and the collector based junction is reverse bias. Now the emitter is heavily doped and base is lightly doped and collector is moderately doped. And I already told you that emitter current is flowing out of the transistor and base and collector current, base current and collector current enter into the transistor. See here, what happened here, this is forward bias, right? So when forward bias means these N type semiconducting material, so N type semiconducting material being negatively charged, so those electrons are repelled by this negative polarity of the battery. Because of this reason, they move forward to the base region and then enter into the collector region. So actually forward by input section is forward bias, output section is reverse bias. Means what? This is forward bias means some current is flowing through this, right? That means low resistance region. So this is low resistance region and this is high resistance region. High resistance region means what? So current equals to 0 ideally. So here low resistance means some current is there, some constant current flowing through this, okay. So here whenever we apply forward bias to the input section, because these electrons are repelled by this negative polarity, they move towards the base and they enter into the base, then it crosses the barrier and then enter into the collector region, right? So ideally output section, that is collector base junction, is reverse bias. Reverse bias means we know there is no current flow, but here because of this region, base region is lightly doped and very thin layer, okay. So for example, we have 100 electrons here from emitter. So from emitter 100 electrons are moving towards the base, enter into the base, but here p-type semiconducting material is base. So base have holes are the majority charge carriers, that too very low majority charge carriers in number, right? So approximately 5% of the electrons will recombine with this holes in the base region. So remaining 95% enter into the collector region and that constitute your collector current. So therefore this emitter current enter into the base region, and because as very few holes are present in the P region, so those few holes are recombined with the sum of the electrons emitted from the emitter, and remaining 95% will enter into the collector region and then constitute the collector current. So therefore, this is the basic concept. So the current flowing from low resistance region to high resistance region, hence it is called transistor, transfer resistance. Okay. So this is the basic concept of your transistor. Now PNP, similar fashion. So emitter base junction is forward bias, and emitter is heavily doped, base is lightly doped, and collector is moderately doped. Okay. So if you apply a KVL, input and output, so you will get this kind of expression, that is sum of collector current and base current gives you emitter current, IE equals to IC plus IB, very standard formula. And now similar process method we can adopt here, that is, this is P side, P type material. So P type material is connected to positive terminal of the battery. So obviously these holes are repelled by this positive terminal and they enter into the base region, and base is lightly doped because base is N type semiconducting material which is having less number of charge carriers. So 5% will recombine with these electrons. These holes enter into the base region, but only 5% of the electrons in the base region will recombine with the holes emitted from the emitter region, and remaining 95% will enter into the collector region, that constitute collector current, right? So this is the basic concept of your BJT, NPN and PNP transistors. Now types of transistor amplifier configurations. So there are 3 configurations, because transistor is a 3-terminal device. It has 3 terminals, emitter, base, collector. So therefore we can configure this transistor 3 different ways. One is common base configuration, common emitter configuration, and common base configuration. Sorry, this is common collector, printing mistake. Common collector, CC, CB, CE, CC. So if you see here, what is common base configuration? So this is common base configuration. Actually, yeah. So this is common base configuration. Second one. First one is common emitter configuration, and third circuit represents common collector configuration. What is common base configuration? Common base configuration means it is base terminal is grounded. It is also called as grounded base configuration, or you can say base terminal is common to both input port and output port, like this. So this is your common base, right? CB. So here base terminal is grounded, or you can say base terminal is common to input side, input port and output port. We can say like this also. Here common emitter, if you consider common emitter terminal is grounded, or emitter terminal is common to both input port and output port. Similarly, common collector, if you take common collector is common to both input port or output port. In other way, collector terminal is grounded. It is grounded collector configuration. This is grounded base configuration, and this is grounded emitter configuration. So these are the 3 different configurations we have. Okay. So what we have learned today, so we have started with the introduction of transistor and its concept, and different types of NPN transistor and PNP transistor and its structure. We have discussed operation, and then construction and operation of NPN and PNP transistor we have discussed. Then what are the transistor amplifier configuration we have introduced, that is common base, common collector and common emitter. So in the next session we will discuss in detail about common base and common collector and its input output characteristics. Thank you.